All right, hello and welcome to Chapter 8, Rational Functions, what we're going to be learning about. This chapter, much like some of the longer chapters from earlier, we're going to split them into two parts. So the first part here is going to be 8.1 to 8.3. So we're going to do those three sections and then take a test. Right, some of the sections will take multiple days, but that's what we're going to do is do the first part of Chapter 8 here. So as far as what a rational function is, like think of that word ratio, right? And then I give a bunch of examples down here and see, I want you to pause the video here and see if you can come up, what do you think a rational function is? All right, so rational means ratio, right? And ratio is just like A over B. And so in a rational function, it's basically going to be like some polynomial, which if you remember, that's like it's got variable x and then the exponent's a number. So a rational function is just one polynomial over another polynomial. Okay, and the polynomials can be really simple. Like here, the polynomial in the numerator is just 1. That can, be really simple or something like that. It still counts as a polynomial, but that's a rational function. It's just polynomial over polynomial. Okay, and so in this first lesson on 8.1, we're just going to learn about kind of like a um, basic rational function, and it's the inverse variation function. And so we'll have some equations and stuff for this, and we'll get them down here as we go. So basically, with inverse variation, there's both inverse and then something called direct variation, which we learned about way back in chapter 2. So I want to contrast these two different variations, inverse and direct. That's how I'm going to start. Okay, so to try and help you just remember, I just have a couple examples for you. So basically, an example of a direct variation would be if you scored 25 points per game in basketball, that was your average. Okay, so we could sort of make a little function that says your points, P, is equal to 25 times however many games you play, G. Okay, and you're probably a little more used to it with Y and X. So if you wrote it as Y and X, it would look like that. Okay, but basically, a direct variation as an equation, you'll have your y and x variables, and then x will be multiplied with k, which stands for the constant. Why the heck they didn't use c here instead of k, I do not know, but that k is called the constant, and it's like a fixed number. Like in this example, the 25 was the fixed number. Okay, so like another example might be if you have a job and you get paid $12 an hour, right? That's a direct variation because your pay is just equal to 12 times however many hours you work. All right, so that's what direct variations look like, is a constant times x. As a graph, they're a straight line linear graph, um, and then they actually go through 0, 0. So it's actually, this is a lot like y equals mx plus b form, but the b is just 0. So it just goes at 0 and then it basically just has a slope. So k, another way to think of that k constant would be to think of the slope. Right? As games go up 1 here, your points go up by 25. You can kind of see that in the table. Okay, so that's what they look like as a graph. And then the other hard part about the equation is, and this is kind of, I would probably write both of these equations down, is I like to think of it at direct variation as just constant times x. That's what it is. But in a table, the way you're going to tell if it's a direct variation is you can divide the y-x pairs, and that's always a constant. Okay, so if you're doing notes here, if you want to put in table form, that's the equation you're going to look for. Okay, and notice it's just, if I take the original equation here and divide both sides by x, divide both by x, I would get this equation. So they really are the same equation, just one has y alone, and the other one has k, the constant, alone. Right, so again, I think this is what gets super confusing here is a direct variation is y equals some constant number times x, but in a table, you don't multiply, you divide, right? So the way you can tell a constant variation is if you divide these pairs and they're always the same. So if I divide y by x, 25 by 1, 75 by 3, and 125 by 5, all of those come out as a constant number of 25. Right? So all of these, sorry, I kind of ran out of space here, but they all equal 25. And that's how you're going to tell that it's a direct variation in a table is by dividing the pairs. Okay, and that would also just get you your constant Okay, and then that would allow us to get the equation. I know we had the equation right away here, but if you have to find the equation, you just divide the y-x pairs. Okay, so my example for inverse variation is, let's see, so inverse variation, let's just see, is like a constant over x. So direct was a constant times x. So inverse is a constant divided by x. That's what it means to be an inverse variation. Okay, and so the other, like the hard part about this is, again, in a table, right, if you were to take both sides of this times x, right, you would get the equation x times y equals a constant. Remember, k is called the constant. Okay, so I listed two inverse variation equations here because I would use the bottom one if I was looking at a table, right? I would look at the xy pairs and see if you multiply them together, and that gives you a fixed number. Okay, but in general, the equation looks like this, all right? K over x. So the example I'm going to give you, remember k is a constant amount. So this is an example from my real life where at one point in my life, me and a bunch of buddies rented an RV, and it was quite a bit. I think it was about 1,000. I just made it 1,000 to make this example simple. But we split that cost among the people. Okay, so like the cost per person was equal to $1,000. That's the constant of variation. That's K, divided by however many people went. Right. So written another way, we could just say y is equal to 1,000 over x. Okay, and that's what a inverse variation looks like. All right, it's just a fixed number, constant over x. Okay, so if I go back here, basically I'm gonna do this. So the cost per person was 1,000 over the number of people. So you could say if I was lonely and just went by myself, it would be $1,000, right? But let's say I got one buddy to join me, so now there'd be two people, and 1,000 divided by two would be 500. And we did have about 10 people go or something like that. So if we divide 1,000 by 10, we'd each pay 100. Okay, so again, like if you didn't have the equation and you weren't sure, like, is this table a direct or inverse variation? The way you'll be able to tell is if you multiply all these together, it's always $1,000. So that's why we say here x times y is equal to a constant. In our case, x times y is equal to 1,000. Right? But it's also correct, again, to divide, if you both divide both sides by x, you could say the cost per person is 1,000 divided by the number of people. Okay. And just kind of as a follow-up here, kind of an interesting side story to this is we had like 10 people going in this RV, and then one of my buddies, Ben, who's always making trouble and problems for us, he backed out. Okay, so now there's only 9 people. So you can kind of think of like how much money did Ben cost all of us by dropping out. Okay, so I'd pause the video and see if you can figure that out. Right, so the new cost would just be, cost per person would be 1,000 divided by 9 people now, and if you do that on a calculator, you get $111. So you can see that if it's only 9 people, the cost is 111. All right, so it cost us about $11 by deciding to back out, which was a bummer because we had less money to gamble in Vegas then. All right, their graphs are going to be weird. I don't want to focus on that too much on this lesson, but they're going to end up looking like these weird functions like this. So like when there was one person, it was a lot of money, but as we got more and more people, the cost goes down kind of sharply, right? Which you can almost see that in the table here. So that's what their graphs will look like. Okay, so let's do some sample problems here. And basically, remember, there's two types of variation: direct or inverse. And direct is just some fixed number times x, and an inverse variation is a constant divided by x. All right, and I guess it could also be neither. But so what I would do in a table to determine the type of variation, I would do either divide. So basically, if you look at the alternate forms of these equations, if I divided by x here, so if it is the direct variation, y divided by x would be a constant. And again, if I multiplied this by x, then we'd have x times y equals a constant. So if it is an inverse variation, you'll multiply them together to get a constant. So I'm going to start with that. I'm going to see if I multiply these xy pairs together, will I get a constant? Okay, and you can see that every time I multiply x times y, I always get 30. Okay, so that means k, the constant of variation, is 30, and the equation is either this, I would take this on the test, or if you divide both sides by x, you could have y equals 30 over x. And I'll try to make a visual for that. Divided by x, right? So that would be an alternate way to write the equation. This is a more traditional way where y is by itself, but in theory, both are correct for this table. Okay, so this would be an example of inverse. Okay, we have a fixed amount divided by x. And I think what really confuses students every year on this lesson is the idea of these two versions, like x times y equaling 30, but it also being true that 30 divided by x is y. And like getting mixed up then, what is inverse, what is direct. And the best way I always remember is I think of this RV example. That's what I think of when I think of inverse, is a fixed amount divided by the number of people. So here we have a fixed amount of 30 divided by x. All right, let's do some more examples. So here's 3 tables for you to try: direct, inverse, or neither, and write the function or equation. So if it is a direct or inverse, write the function that goes with it, right? So that'll be like the y equals k times x or y equals k divided by x equation. Okay, so what I do is I start by multiplying across and see if they're the same. So 8 times 0.2 would be 1.6. 0.5 times 20 would be 10. So already I can tell that that's not going to work. Okay, so since that didn't work, next what I would try for this table is I would do y over x and see if that's constant. So I'm going to do 8 divided by 0.2, probably use my calculator, and I'm going to check, is that the same thing as like 20 divided by 0.5, and then 40 divided by 1, I'm doing this direction, right, y over x. 60 divided by 1.5. Okay, and what we'll find is that all of those equal 40. Okay, so all of them equal 40. So in this table, it's correct to say that y divided by x was always 40. All right, and then if I solve this, right, for y and multiply both sides by x, I would get y equals 40 times x. Okay, and now I am to a direct variation. Right, that's like scoring 25 points per game, except now we're scoring 40 points per game. It's a constant times x. So that's an example of direct. Sorry, I'm running a little low on space here. But let's try letter B. Okay, so I'm going to multiply across again, see if that holds the same all the time. So this one is 8, 8, 8, and 8. So I think those are all 8. Okay, so we could say that in this case, when we multiplied x times y, we got 8. Okay, so that's one equation, but then I'm going to get y alone, so I'm going to divide by x, and I'm going to write y equals 8 over x. Okay, so that's my equation. And you could also have written y times x here, x times y equals 8. I would take that too. But then again, this is this inverse. Right? This is like you have 8 cookies and you're dividing it among some people, and that's how much each person gets. Right? That's what inverse is, a fixed amount divided by x. Okay, last table. When I multiply across, I get 20. And then I think this is like 14.4, and this one is 20. And then the last one would be 15. Okay, so x times y is not a constant, right? X times y is not constant, so it's not that type of equation. That would be an inverse one, right? So now let's try to divide them, right? Let's see if we do y divided by x. So 40 divided by 0.5, I want to say is that thing is 12 divided by 1.2, and I can already tell that those aren't equal, right? This one is 80, and that's not equal to 10. Okay, so it's also true that y divided by x is not a constant. Okay, so this last table would be an example of neither direct nor inverse variation. Okay, so kind of a lot going on, but I always start with x times y or x divided by y when I have a table.